So, we have already talked about the basics of roots. We know that the root of 9 equals 3.
Yeah.
Because the root of 9 means...
3 times 3.
3 times 3, very good. Or something squared, or something times itself, equals the base of the root. Now, or the number in the root. But there's some kind of fun things we can do with roots. And that kind of root, by the way, is actually called a square root. This is going to be important. A root like this is a square root.
Yep.
There's a hidden number in here. It doesn't show you, but it's right here. The hidden number is 2. Do you have an idea as to why it would be 2?
Because it's 16, 4 squared.
4 squared. Squared. The 2 could go up here. 4 squared equals 16. Very good. Okay. So, what if... I'll take that funny looking D thing away. We had a cube root. Let me just write in a square root over here so we don't get confused. The root of 81. What do you think a cube root would look like?
A cube root would look not squared to any of the numbers in the multiplication.
Yes, it wouldn't be squared. That's absolutely it. But it would involve multiplication, like you said. So remember, the square root has a hidden 2 right here. For the cube root, it's actually a number you have to write in. It's a 3. And then we put our number in here. So let's do 8. The cube root of 8.
Is 6.
It's a tricky one. Now let me teach you. Something cubed equals 8. 6 cubed is a huge number. That's 6 times 6, which is 36, times another 6, which is 216.
2 cubed.
2. The cube root of 8 is 2. Not 2 cubed, but the answer is something cubed. Actually, here we go. Something cubed equals 2. What do you think about the cube root of 27?
That's 9.
Ooh, that's a tricky one. When people just learn about it, they always think it's 9. It's not 9. 9 times 9 is 81. Times another 9 is a huge number. 729, I think. 3.
It's 9 times 3.
Very good. 3 times 3 is 9, times another 3 is 27. Beautiful. So these are all cube roots, as opposed to square roots like this. Okay, now let me erase all that, and let me show you something that I hope will blow your mind. We know from BEDMAS and from other things that something squared, or something cubed, or something to the power of 4, is something times itself a number of times. So for example, 4 cubed equals 4 times 4 times 4 equals 64, right? Right. But that's making numbers way, way bigger. And a cube root of 64 equals this small number 4. Sorry, my 4s are a bit off today. So this one makes numbers way bigger, exponential. This one makes numbers way smaller, roots. So what if we combine them?
Combine them both?
Yeah, what about this? Just have a look at this. Tell me what you think. Well, hang on. No, sorry. Let me think that one through. Let's do a square root first. Square roots are easier to deal with first. Isn't that a funny looking question?
Yeah.
The square
5
root
squared.
of 5 squared? What's that going to turn out to be?
It's going to actually turn out to be 10.
Good guess.
No, 25.
So you've done the first step. The root of 25. What's the root of 25?
It's 5.
Yeah. Hey, isn't that where we started?
Yes.
Whoa. What about the square root of 7 squared?
4.
Hang on, slow. Think about it for a sec. The square root of 7 squared. Remember here, our final answer, we ended up back where we started. What do you think the square root of 7 squared is?
7.
Yeah. And that's because if you square 7, it turns to 49. And if you take the root of 49, it ends up being
7.
7. Huh. Do you think the same thing applies to cube roots?
Yeah. No, it doesn't.
Let's take a look. There's 3 3s in this question. Can you read the question what it sounds like to me? What does that question sound like out loud?
The question is 3 cubed. 3 cubed.
The cube root of 3 cubed. Very good. You got 3 cubed down.
That would end up being 3 cubed. 3.
It would end up being
3.
3. Very good. Why would it end up being 3?
Because it's 3 cubed.
3 cubed is 3 times 3, which is 9, times another 3, which is 27. 27, and the cube root of 27 equals?
9. That's 3.
3. Yes. So is it almost like this exponent and this in the root cancel out?
Yeah.
And you're just left with this?
Yeah.
Well, let's try that. Let's try that with some pretty crazy numbers and see what happens. We'll pull out our graphing calculator if we need to. I believe 451 was the time of the song that you assigned me for homework that was way, way, way too long. So I thought I would use that number right here. The square root of 451 squared. What do you think the answer is?
It's 451.
Yeah, 451. So what cancels out?
The 2
The 2 and the?
and the 1 and the key square.
That's right, or the imaginary 2 there. They cancel out, and you're just left with 451. Now let's take out our graphing calculator really quick.
Was that really how long the song was?
Yeah. So we're going to do the root of that number. Okay?
Yeah.
The root of 203,401.
451.
Ah, cool. So it always seems to work. Isn't that nice?
Yeah.
That is nice. Alright. That's actually all I wanted to show you about roots, unless you have any more questions. Feeling good?
Yes.
Solid.